we are going to use this. I would recommend writing this down. So the rational zeros theorem. Tells us if you have a polynomial with only integer coefficients, so there's no fraction coefficients, no imaginary coefficients, nothing crazy, then all possible zeros are going to be of the form P over Q, where P is a factor of the constant and Q is a factor of the leading coefficient. Gives us the list of things that might be a zero. A zero, remember, is an x-intercept. It's something that when you plug in that number, it makes your y value zero. It doesn't tell me which ones are, just which ones could be. But only the rational ones, the nice ones. So we know we can have imaginary zeros. We might have something with radicals, like not everything is all pretty. This gives us a starting point of things that could work to divide it, and we'll use that to figure out which ones do work. You will need a calculator today, so if you don't have a calculator, make sure you grab one. So when we go through, the first thing that we will do is list the possible zeros. Then from there, we'll figure out which ones work, and that will give us our starting point. Remember, we've had some problems before where I gave you the first zero, and we would start with synthetic division with that zero. So it's the same idea. We just have a couple more steps. We have to find the first zero ourselves, and then we'll be able to start our problem. So let's say my polynomial is 2x cubed plus 11x squared minus 7x minus 6. How many zeros will this one have? 3. It's a degree of 3, so we'll have 3 zeros. Okay, we are going to come up with a list of things that could be zeros. So we're going to start with our P and our Q. P is everything that is a factor of the constant. So every number that could evenly divide negative 6. So what could I divide negative 6 by? 2, 3, 1, and 6. Does it matter if it's positive or negative? No, so there's really 8 numbers. Positive and negative 1, positive and negative 2. So on these, we just write it as plus and minus. So we could do 1, 2, 3, and 6. Those are the only numbers that divide 6 without a remainder. It doesn't matter what order you write them in, so as long as you have them all, that's all I care about here. Q comes from the leading coefficient. So what is every number that can divide 2? 1 and 2. And again, they can be positive or negative. So all of these will always have plus and minus on them. So now we can make our possible zeros. The possible from that theorem is P divided by Q. So we are going to divide all of these. So 1 divided by 1 is 1. And again, could turn out to be positive or negative depending on what combination of signs I picked. If I did 1 divided by negative 1 or positive 1 divided by positive 1. P over Q. So I could do 1 over 2. Plus or minus 1 half. I could do 2 divided by 1. That will give me a positive and negative 2. I can do 2 divided by 2, which is 1. I already have 1, so I don't have to write it again. I can do 3 divided by 1. So we may have 3. 3 divided by 2. 6 divided by 1 is 6. And 6 divided by 2 is 3, which we already have. Okay, so that is everything that could work. Do you guys understand how I got that list of numbers? So I went through and I had to do P divided by Q. So I did each P, 1 divided by 1, 1 divided by 2. The next P, so 2 divided by 1, 2 divided by 2, 3 divided by 1, 3 divided by 2. So we went through the entire list and divided them. Okay, these are things that could work. If they work, that means they are a 0, so it's an x-intercept. Now, we don't have our graphing calculator, right? So we can't just look at a graph and tell. The other option, if it's an x-intercept, that means when you plug in the number, it has to equal what? 0. So what we're going to do is take this list of numbers, plug them in up here until we find one that makes it 0. Okay, you don't have to show work for that. That's pretty much all on your calculator. But I usually start, I try to avoid my fractions if I can. So like if I'm on my calculator, I'm going to plug in. Now if I plug in a 1. And do you guys know, if we're using the graphing ones, if you hit second enter after you type this in, it'll bring it back up. So then I can just go and change my 1s to the next number. You don't have to retype the whole thing every time. What happens when I plug in a 1? It equals 0. So we just found the first real 0. 1 works. So now this is like the problems we had, seems like forever ago, but really just last week, where I gave you the first 0. And once you have the first 0, what do we do with it? So I'm going to do my 1, and we write down our coefficients. 2, 11, 7, 6. Now, there are 3 zeros here. I found one of them. If you're doing it, you may have very well found a different one to start with. It doesn't matter which one. Okay, you just have to find one that works, and we'll divide it. And how do we know it works? If we get a remainder of 0. Okay, so when I plug in the 1, I got 0 out. That's how I knew it worked. So 2 comes down. 2 times 1 is 2. 11 plus 2 is 13. 13 times 1 is 13. We have 7 plus 13 is 6. 6 times 1 is 6. Negative 6 plus 6 is 0. So my remainder, constant x and x squared. So we have 2x squared plus 13x plus 6. Now we could go back to our list of zeros and try to find another one. But at this point, what is it going to be easiest to do? Slip and slide. Is everybody with me at this point? So if I slip and slide. Multiply 12 and add to 13 would be 12 and 1. Divide by 2. So that gives me x plus 6, 2x plus 1. Okay, my questions. I want the zeros and the factored form. Factored form, it was an x to the third, so I expect 3 parentheses. What's my other one? My zeros, what makes x plus 6 equal 0? What makes 2x plus 1 equal 0? And x minus 1? Were all 3 of those numbers on my list of possible zeros? Yes. Now, it's not always going to turn out that every 0 is on this possible 0 list, because we know sometimes when we have quadratics, if they don't factor, we have to do quadratic formula. We might get imaginaries or radicals. Those numbers aren't on our list of possible zeros. It only gives us the nice ones. Okay, so that's why once we find the first one, we have to start with our division.
So the P of Q.
P over Q.
Yeah, that gives us our possible zeros versus, which gives us a 0 to start with.
Mm-hmm. And then it's like our problems from before. this is all we're doing today, so let's keep practicing. This time I am going to have you guys find the zero that works the first time, so make sure you have a calculator if you haven't already gotten it. So, our next polynomial. How many zeros is this one going to have? 4. How do we know that? This exponent, the highest exponent is 4. Is this one that I could just factor nicely? No. We had an x to the 4th on our homework, but that one was easily factored. This one is not. So, we have to start with our p's, q's, and possible zeros. Where do we look for the p-value? What is everything that goes into 2? Then we need our q. Where do we look for the q value? A leading coefficient of 6. What's everything that goes into 6? Gave you the same coefficients as last time, I just flipped them. So our possible zeros. Possible zeros, that's p divided by q. So we do each p divided by each q. So 1 over 1, and plus or minus 1. 1 over 2. 1 over 3. 1 over 6. And you have to put the plus or minus on all of them. It's annoying, but it is necessary because those are actually 2 different zeros. Alright, then we have 2. 2 divided by 1 is 2. 2 divided by 2 is 1, and I already have it. 2 over 3. 2 over 6 is 1/3, and I already have that. So here is my list of possible zeros. My suggestion, I always try the integers first. So I would try 1, -1, 2, and -2 first. They're a little bit easier than the fractions. So why don't you guys try 1, please? You want to try -1. You guys try 2. You guys try -2. If you find one that works, let me know. And how do you know if it works? It equals 0 when you plug it in. Do 2 this time.
How do we do, if it's a negative and a positive, which do you do, the negative or the positive?
You have to check both. So whichever number. So like you would check +2. If it didn't work, then you plug in -2 and see if it works.
Could they ever repeat, like possible?
Yes. Yes.
And those would probably be multiple zeros.
All right, so if we do our synthetic, 6 comes down. 6 times 2 is 12. 7 plus 12 is 19. Are we sure? What?
It was -2.
-2, okay. Let's fix that.
That's good.
All right, so this would be a -12. So if we add those, that's -5. -5 times -2 is +2.
Yeah, 2 makes 3 and 12.
Yeah, I was gonna say this does not look good so far. Okay, 2 times 4 is 4. 1, -2 and 0. All right, so what I have right now is 6x cubed minus 5x squared minus 2x plus 1. Is that something I can factor easily? We could try grouping. If you do, Are we going to be able to get two identical parentheses? No. So our strategy for 4 terms from the past is grouping, but it doesn't work here. Do you have any other ideas what we would do then? Brent? We could try to take out an x, but the constant doesn't have one. So we're back to a polynomial we can't factor. But what else did you guys tell me was a 0? 1. So we could do synthetic again with positive 1 and the answer we just got out. Now, if we didn't already know that 1 was, we would go back to our list of possible zeros, start plugging them in here, and seeing which one worked. Anything that didn't work the first time will still not work. So if you checked positive 2 and it didn't work, there's no point to check it again. But negative 2 worked the first time, we could check it again because it might work a second time.
Could it not work?
Yes.
So we need to check.
6 comes down, 6 times 1 is 6, 5 plus 6 is 1, 1 times 1 is 1, 1. So this gives me 6x squared plus x minus 1. Is this something I could factor? Yes, we can do slip and slide. So that would factor into x plus 3 minus 2. Divide our 6 back. Alright, so my factored form is all the parentheses. I have 2 of them. What else do I need? X plus 2, because negative 2 is a 0, and x minus 1. So my zeros, if you set each of those equal to 0, we get negative 1/2, positive 1/3, negative 2, and positive 1, which were all on my list of possible zeros to begin with. What questions do you guys have so far? When I tell you to plug in your number and check it, does everyone know how to do that? You know what I'm asking? I have a couple more. I'd like to do at least one more together. We can do both if we need to. Remember, factored form is with the parentheses. Zeros are just your numbers. How many zeros am I going to get this time? 5. And we know that because it's an x to the 5th. So probably going to end up doing synthetic division a few times here. P's and Q's. What are my P values? I think that goes into 48. There's a lot. So you can do 1 and 48. 2 16, 4 and 12, 6 and 8. Q. Where do we look for the Q? Leading coefficient. This is just a 1. So everything that goes into 1 is just plus or minus 1. So possible zeros. P over Q. What do we get?
Just all those top numbers.
Yeah. All the p values. 1 over 1, 48 over 1, 2 over 1, 24 over 1, 40, just dividing each of them by 1. If that happens, you're welcome to just draw an arrow up to your p values if you don't want to copy them all down again. So we have a lot of things that could work here. We need to find something that works. And if someone else's number works, just hang on to that. We might need it in a second. So 1 comes down, 1 comes down, 3, 6, 3. Are we down to something that factors nicely now? No. So we have to find another 0 that works. Did anyone else's number work? No? All right, plug in -3 again, see if it works. Let's check the rest. So, everybody check a number, let me know when you find one. Everybody should be checking right now. I think 2 works. Not sure who was my 2 person, but that should have worked. We plug in our coefficients. We'll do our synthetic again. The answer we got out, +2. So 1 times 2 is 2, -4 plus 2 is -2. 4, 4. What do you guys want to do now? We can either check with this factor nicely, if you remember grouping. If you forgot grouping, you would go back and find another 0. Keep plugging your numbers in. So if we do grouping here, take x squared out of the first one, x minus 2. Take 4 out of the second one, that's x minus 2. 2 and the negative 3. Okay, so we need our factored form and our zeros. When I get here, does x squared minus 4 factor, or sorry, x squared plus 4 factor? Not nicely, right? We also had x minus, or a negative 3 as a 0, so that means we get an x plus 3. And we have a 2, which means we need an x minus 2. But when I'm looking at that, do I want to write x minus 2 twice? So what would I do?
X minus 2 and 2.
Yeah, for our zeros, we put it as a multiplicity. For that, we square it. So our zeros, if we set x minus 2 equal to 0, we get 2 multiplicity of 2. If we set x plus 3 equal to 0, we get negative 3. If you set x squared plus 4 equal to 0, what happens when you do the square root? What do we get? Plus or minus 2i. So we said 5 zeros. We have 2 2's, a negative 3, a positive 2i, and a negative 2i. We got all of them. For your factored form, if you had wrote x minus 2 squared, x plus 2i, x minus 2i, and x plus 3, I will also take that. So on the factored form, if you don't factor out the i's, that's fine. If you do, that's fine. You can write it either way. All right. There is a Math Excel assignment open.